Particles P and Q of masses m kilograms and 0.05 kilograms respectively are attached to the ends of a light inextensible string which passes over a smooth pulley. Q is attached to a particle r of mass 0.45 kilograms by a light inextensible string. The strings are taut and the portions of the strings not in contact with the pulley are vertical. P is in contact with the horizontal surface when the particles are released from rest. The tension in the string QR is 2.52 newtons during the descent of R. Find the acceleration of R during its descent. By considering the motion of Q, calculate the tension in the string PQ during the descent of R. Find the value of M. R strikes the surface half a second after release and does not rebound. During their subsequent motion, P does not reach the pulley and Q does not reach the surface. Calculate the greatest height of P above the surface. Okay then, so here's the question. Find the acceleration of R is the first thing. So pen, maybe we could put that over here in this space here. So one part A. Let's apply acceleration of R. So R has weight 0.45 g. Also Q has weight. Let's put some other forces in. This is 0.05 g here. Now the weight here will be mg. When P is released from rest, it's going to accelerate with the acceleration A. I've put a tension in the string here already, and it's going to come down here with acceleration A. So let's apply F equals ma, acceleration of R. So it's going downwards, so let's apply F equals ma in the downwards positive direction then, so to speak. 0.45 g is the weight, minus the tension in the string, is equal to the mass, 0.45, times the acceleration, that's F equals ma. So A is equal to then 0.45 g minus the 2.52 divided by 0.45. So the acceleration then, tap it in the calculator, just move it over here. So we've got 0.45 g minus the 2.52, that's the top number, divide by 0.45 equals 21 over 5, which is 4.2 meters per second per second. So there's the acceleration downwards, so we know that. So let's put that in the diagram then. Here 4.2 and here 4.2. Okay, right, good. Now calculate the tension in the string PQ. So I'm going to put part B over here now if I can. See if we've got room. So we'll apply F equals ma in the upwards, in the downwards direction then at Q. So 2.52 plus the weight 0.05 g is equal to well, that's the two weights going down, minus T, tension going up, is equal to the mass, which is 0.05, times the acceleration, which we know is 4.2. So now we can work out tension now. The tension is equal to then, move the tension through the equals here. So leave these two numbers as is. So there's those two. And then move this one over the other side to be with them. Minus 4.2 over 20, that is. So I'll put it as a fraction to save space. So tension equals then. Let's tap it in the calculator. So we've got 2.52. Plus 0.05 times g minus 4.2 and it was times the 0.05. In other words, it's divided by 20, that number, equals decimal 2.8 newtons. So there's the tension in the rope around from P to Q. There's the tension in it. So find M now, part 2, find M. Let's have a look at here. So part 2. Let's apply F equals MA here in the upwards direction. So T, which we know is 2.8, minus the mg is equal to the mass, m, times the acceleration, which is 4.2. So that tells us then, if we move the mg over, mg, and then there's an m common, so put the m outside a bracket, so it's mg plus 4.2 then, is equal to the tension, isn't it, which we know is 2.8. So that tells us what m is. It's 2.8 divided by g plus 4.2. So tap that in the calculator then, 2.8 divided by brackets g, 9.8 plus 4.2. Close bracket equals 0.2, 1/5 of a kilogram. So there's the mass here of this object. So now we know the acceleration, we know the mass. Good. So part 3 now. R hits the ground 0.5 seconds after release and does not rebound. Find P's greatest height. So part 3. So what have we got then? We've got a situation where this particle here, R, which is released from rest, so U equals 0, is going down with acceleration of 4.2. It hits the ground half a second later, it says in the question. T is equal to 0.5 seconds. Okay, now P over here was at ground level. So the height here that this falls will be the height that P rises to here. Okay. So this will be h as well. So that's the first thing we need to work out. And then, okay, so we've got that then. So let's work out that height. The acceleration, we don't know the velocity here. And we don't know the, okay. So is there anything else we know? We know the time. So we can use v equals u plus at, can't we, here? So let's do that then. So v equals u plus at gives the final velocity is here, is equal to, or we could use s, because we just want the distance, don't we? We don't need the speed so much necessarily. So let's get the distance. S is equal to ut plus half at squared, isn't it? That's the best one to use. So this formula then gives, we know u is 0, so s will equal half a, half of 4.2, times the 0.5 squared, which is t squared. So half of 4.2 is 2.1, so I'll put it in straight away, times 0.5 squared. 0.525. And that's meters. So h is equal to 0.525. So there's where P goes to here then, from here. Now once it's got to here, Q no longer affects the motion. So it's as though it's not there. So P will be here. It will go over the pulley here, which I can, well, I'll try and draw it a bit better than what I've just done. There's P. Here's the ground. Here. This height here is 0.525. Q is now come down to wherever. And R doesn't enter into it because it's a loose string. So we don't need to worry about R, because it's not going to have any motion bearing on the forces. There's a new tension in the string now, which we'll call T dashed, because there's only this mass here, which is of 0.05. So the weight is 0.05 G. The weight of this is, the weight of P is M, which is 0.2. That's the force there. We now know there's a new acceleration, which we could call A dashed. And A dashed. Okay. We may need to find out the velocity here to get the height, because we're going to find out the acceleration here. So we may need to return to this to get the velocity. But let's just work on this for now and find the new acceleration. Presumably it's a negative acceleration. Well, it will be because this is a bigger mass. So this is P now and this is Q. So let's have a look. So I'm going to keep it that way around. So T dash then here minus 0.2 G is equal to 0.2 times A dashed, and here it's going to be 0.05 G minus the T dashed is equal to 0.05 the mass times the acceleration, which is downwards. Okay, this is 1, this is 2. Add them, you get 0. Oh, that's a minus, that's a plus, so it's minus 0.15 G is equal to 0.25 A dashed. So A dashed then is equal to minus 0.15 G over 0.25. 3/5 that is, minus 3G over 5. So there's our new acceleration, which is negative. Now we need to get the height, we're going to need the velocity that this has initially. So what is the velocity here? Well, it will be the velocity that this hits the ground at, R hit the ground at here. U squared plus 2AS, isn't it? So I'm going to put that in here. Also, V squared equals U squared, 0, plus 2 times the acceleration, 4.2 from before, times the distance is 0.525. And that will tell us what V is when we square root the answer. So I'm going to do that in one fell swoop. 2 times 4.2 times 0.5 squared times 0.5 squared equals 2.1. 2.1. Oh, I got to square root that though. So that was that number there. And then we square root it. So square root of the answer then. I'm a bit worried about this, but it says square root answer. I'm going to cancel that. I'm going to do it again. 2 times 4.2 is 8.4. So it's 8.4 times 0.525. There we go. So that's that. Okay, now square root answer, which is 2.1. I had square rooted it. Okay, good. So that's 2.1 then, meters per second. So this velocity here then we've just discovered now, here P is now going to go up with acceleration A dashed, which is equal to minus 3G over 5. It starts off with a velocity here of 2.1. So we need ds, don't we? We know the top velocity up here will be v equals 0. So v squared equals u squared plus 2as then. gives 0 squared is 0, u squared is 2.1 squared, plus 2a, minus 2 times 3g over 5 is 6g over 5, times the distance s. So that tells us then that s is equal to, move this over there, 2.1 squared, and then move the 6g over 5 underneath, 6g over 5, the 5 swings up. So there's a little bit of algebra there. So s, then this little distance that p has gone up under the tension is this. So square this number. Okay, times by 5, divided by 6, and then divide by g. Type it in the calculator, 3/8, 0.375. So answer then is equal to, well, this height is 0.525 plus the height that it moved here to the greatest height, 375, before it starts moving down, 0.8, 0.9 of a meter.